Okay, so ladies and gentlemen, the first thing I want to talk about is complementary, supplementary, and vertical angles. Okay, so I don't think we need to spend a ton of time on this, but it's a good just get the and guys, here's the deal. So these are free, easy points. Okay, so in the test, if you these definitions, a lot of these definitions are going to be free, easy points. So know them. So who can raise their hand and tell me what is a complementary angle? When we're dealing with a complementary angle, Austin, what are we dealing with?
Isn't it angles that add up to 90?
Very good. So let's write this down. If it's already in your notes, let's just get it on a study guide. Two angles whose sum, that means add to, is 90 degrees. Now, a couple things about complementary. It's two angles. It's not 7 angles. It's not 90 angles. Okay, you can't have 91 degree angles and say they're complementary. It's two angles, right? So if I had and I'll just do a little picture off to the side. If I had an angle that, we'll call this angle A, and I know angle A is, let's say I know the measure of angle A is equal to 36 degrees. And let's say I also know that angle B over here, it's just a bad drawing, I'm sorry. Angle B, if I know that angle A is complementary to angle B, what do we know the measure of angle B has to equal? What is it?
54.
It has to equal 54 because they're complementary. They have to add up to 90. You guys see that? Now, we could also look at the adjacent example. So if we had a right angle, and this is all a little bit of review here. A right angle is always symbolically drawn with a box in the corner, right? So we don't have to say. And so if I had a ray shooting out of it, okay, and I know we can say this is angle 1 and this is angle 2. If I know the measure of angle 1 equals 27 degrees, what's the measure of angle 2 have to equal, class? 63 degrees. Okay, now notice I never said that they're complementary. How do you know those two angles are complementary without me having to say? Right. Yeah, that's angle addition postulate right there, right, guys? Okay, supplementary angles. Write down what you want. Don't write down what you don't want. Okay, it's up to you. This is a study guide for the test on Thursday, and this will be, just simple stuff like this is going to be on the test. So easy free points here. All right, supplementary angles. Xavier, what do you got for supplementary angles? Okay, two angles whose sum is 180 degrees. Again, supplementary, I've said it before, supplementary is much more common in geometry and helpful in geometry than complementary. Complementary is not bad, but supplementary is just a lot of supplementary there. Did I do something wrong, Sam?
No, I was just wondering if we can use these study guides on the test.
You can't use the study guides on the test, but you can transfer anything you need onto a note card. Okay, what?
You only get one note card.
One note card, front and back. Yep. All right, so ladies and gentlemen, if I have two angles here, and I know the measure, look at that, nice, of angle A, if I know the measure of angle A, is equal to 89 degrees, okay, what is the measure of angle B have to be that is supplementary to angle A?
91 degrees.
What is it? 91 degrees. Okay. So angle B over here, ladies and gentlemen, that has to be 91 degrees. Okay? Y'all see that? Okay, so this is just basic definitions. No big deal, not a lot of thinking here, simple math. Okay, vertical angles, really, really big one. Okay, vertical angles happen, guys, when two lines intersect, right? It's the opposite. I always call it the opposite angles. Opposite angles when two lines intersect. That's how I kind of like to think of vertical angles. Okay. Now, so if we have two lines, call that line whatever, and then we have another line here, right? I'll make it red. Okay. When two lines intersect, we get two pairs of vertical angles. Okay. So let me just number these angles here. Sorry, it's a little small here. So if this is angle 1, 2, 3, and 4. So guys, what would be the vertical angles here? Someone raise their hand and tell me, what are the vertical angles that we have here? What are the vertical angle pairs on this example? Martin?
1 and 2 and 3 and 4.
Okay, very good. So angle 1 and angle 2 are vertical. Does everyone understand that? Angle 3 and angle 4 are vertical. You guys doing okay with this? Okay, now, here's the deal. We proved something very important about vertical angles. We proved it. It was our first proof in here. We actually subtracted an angle off each side. What do we know? We have a very nice theorem about the vertical angles. What do we know about the vertical angles, guys? Vertical angles theorem. So we probably need to remember that. So under vertical angles, we need to remember also the vertical angles theorem. Vertical angles are always congruent. So just remember that. Vertical, if I could spell it. Vertical angles theorem. And guys, what does the vertical angles theorem state? What does the vertical angles theorem state? Let's get some sticks here, because you guys need to wake up. Okay, all right. Second period. Who hasn't pulled sticks yet this year? Who has never pulled sticks? Austin, you're stick puller. Austin.
No.
Okay, Austin, pull a stick. There you go. I need you guys to wake up a little bit. You guys are on a candy comas. All right, Brady, what does the vertical angles theorem say?
If there's two lines going next to each other, then that and they create vertical angles, and vertical angles are always congruent.
Okay, very good. If, this is what it says, if two angles are vertical, then they are congruent. Okay? There's our symbol for congruent. If two angles are vertical, then they are congruent. It's written in a conditional statement, and if then. Okay. You guys with me on that? Okay, let's move on. So you're gonna have to apply and know when to use the vertical angles, and we'll take a look at that here in a second. Okay, all right. Adjacent angles. Awesome. Pull me a stick. George. If two angles are adjacent, what do we know about them?
I believe that they're added to 80 degrees of supplementary, and actually that's what I think it is.
Okay, so let's just get this cleaned up a little bit. Let's write this in an if-then statement. If two angles are adjacent, then they share a common ray. Then they share a common ray. So guys, let me say it again. If two angles are adjacent to each other, they share a common ray. So if we go back to that example where we had that right angle, okay? Let's say this is a right angle, okay? And we have a ray coming out of them, like I'll do this green ray, okay? And it can be right angle or not right angle. You don't need to know that right now. But this angle 1 and this angle 2, angle 1 and angle 2 are adjacent. Why are angle 1 and angle 2 adjacent? Why, Sam? Why?
They share the same green ray.
They share the same green ray, right? You guys see that? So in this example right here, ladies and gentlemen, if we go back up here, this example right here, is a special example because they're complementary and adjacent. You guys see that?
Okay.
Here, they're complementary, but they're not adjacent. You guys understand that? Here, they're complementary and adjacent. Now, if we're talking about complementary and we're talking about adjacent and supplementary, that's a very, very, very special situation, right, class? Because if you're talking about two lines that are two angles and they're complementary, excuse me, I keep saying that. If they're adjacent and supplementary, like aren't these two angles right here, ladies and gentlemen? 1 and 2. Why are they supplementary, guys?
Because the two angles add up to
180 degrees. Why are they adjacent?
because they share the same ray.
They share a common ray. So remember, a linear pair. Let's do it in a conditional statement. If two angles are supplementary, okay, which means they're going to add up to 180 degrees, and adjacent, then they are a linear pair. Okay, you guys see what we're saying there? And we've done all of this. So what I'm doing is just going back, we're just getting it all in nice little packages here so we can study for it. Sound good, guys? Okay, so we start this today with a little bit of, just a little bit of vocabulary, definitions, stuff like that. Now, what are some problems we could see? Well, I have some, let's try this. Okay, so here's what I want you guys to do, and I printed all this out, so this is really nice. I want you to go through, and I want you to determine whether each pair of angles is vertical, linear pair, or neither. Select the correct answer for each lettered part. So this is going to make you figure out, okay, how to name angles and decide whether they're vertical, linear pair, or neither. And then, remember, guys, the given is that angle AFB is equal to the measure of angle EFD. Okay? So I want us to use that information to know the measure of angle AFE, and I want to use that information to find the measure of angle DFC. So I'm going to give you guys some time, and then I'm going to have Austin just start pulling sticks, and we're going to just go right down the row here. So get ready. I think I'm going to give you guys 3 minutes, so go ahead and give it a try. So this is kind of the type of stuff you're going to see on your test, all right? Can you apply these definitions to problems? And what I'm hoping is that you guys are going to like, oh, yeah, I remember this. Oh, I forgot that, but now I remember how to do this. Or I wasn't here, but now I see. Okay, so that's our goal. And I see Kaylee over here has her notes open, kind of re-looking at her notes. That's great, okay? And then in the end, you want to just, my suggestion would be for your note card, don't write stuff down you already know. If you know that the definition of supplementary and you're pretty sure you're not going to forget it, don't worry about it. Don't write it on your note card. Only write stuff you need. But if you want to have a thorough note card, that's up to you. Okay, about 1 more minute, and I'm going to start pulling sticks on this. Yeah, do as many as you can. Yep. And the nice thing that they did on this problem, they actually marked using arcs to congruent angles, right? So that's even better. Yep. Tegan. Okay, let's do it. So, Austin, pull me a stick. So the first thing is angle BFC and angle DFE. Who is it, Austin? Okay, Sophia. So we're looking at, let's see those angles. BFC. So BFC, we're looking at this angle right here, Sophia, right? And we're also looking at DFE. DFE. So we're looking at those two angles right there. So what do you know about those two angles right there, Sophia? They're vertical angles. Okay, very good. So now what could, I didn't ask for it, so but what information in your head do you, whenever you see vertical angles, what's the little thing, the alarm that goes off in your head? Vertical angles are congruent. So right away, I guess we could, if we know they're vertical, we could add another arc here. Does everyone understand why? So because if those two are vertical, then we could add another arc. So now we know that three angles are vertical to each other. Do you guys see that? That's the transitive property. If one is vertical to the other and the other is vertical to the other, then the first and the last are vertical to each other. Okay, good. All right, awesome. Pull me a stick.
Cody.
Okay, Cody. So we're looking at angle BFA. So angle BFA. So we're looking at this guy right here, Cody. And we're looking at angle DFE. DFE. Okay, we're looking at those two angles. So what'd you say? Yeah, they're neither. I think they are congruent to each other, but they're congruent because of a given. Is that right, guys? They're not congruent because they have any relationship. They're congruent because of a given. So it's neither. Yeah, how many agree with Cody on that one? I think that's good. Nice job. Well done, Cody. All right. Awesome. Pull me a stick.
Chris.
All right, Chris. So, Chris, we have angle BFC. So, BFC. So, we're talking about this angle right here, right, Chris? And then we have CFD. CFD. So, this angle right here, Chris. So, what do you know about those two angles, Chris? They're a linear pair. Does everyone see that's going to be a linear pair right there? So, they are a linear pair. Very good, Chris. Nice job. So if you look at that, from here to here is a 180 degree angle, straight angle. So definitely a linear pair. Nice job, Chris. All right. The next one, let's look at B. Austin, who is it?
Xavier.
All right, Xavier. We got BFE.
No,
AFE. So we're looking at this guy right here, right, Xavier? And then we're looking at AFC. AFC. So these two angles right here. What do you think, Xavier? Linear pair, right? What's the common ray they share, Xavier? Okay, now a ray is a straight line, right? So ray, you just use two letters. So they share the ray FA, right? So the common ray that they share is ray FA. Okay, see that? Okay, good. All right, nice job, Xavier. All right, next one. Here we go. The next one is Martin. All right, Martin. We got BFE. BFE. So, Martin, we got this mamba jamba right here, right? And then we got CFD. CFD. So, we got this mamba jamba right here. What about those two angles, Martin? They're vertical. Y'all agree they're vertical? And Martin, what do we know about vertical angles? They are congruent. Nice job, Martin. All right, you guys are doing so well with this. Okay, awesome. Pull me a stick.
Wyatt.
All right, Mr. Wyatt. Now, Wyatt, we're looking at AFE, right? So AFE. And we're also looking at BFC. BFC. We're looking at these two angles right here, right, Wyatt? What do you know about them? They're neither. Very good. Okay. They're not vertical. They're not a linear pair. Good. Good job, guys. So I'm hopeful. I think you guys are going to do well. You guys are seeing this. Good job, guys. Okay. Now, if we want to find the measure of AFE, so let's go back. We want to find the measure of AFE. Okay, we want to find this measure right here. That's wrong. AFE. We want to find this measure right here, right? Okay. We also know that this angle here, I believe, is 50 degrees, right? And this angle here is 50 degrees. Okay, so how can we figure out the measure of angle AFE? Chris, you want to volunteer on that one?
So you do 50 plus 50, and that's 100.
Okay, so we add the two 50s plus 50, and we get 100 degrees, yeah?
And you subtract that from 180.
Because it's a straight line. So you take 180 minus 100, right? And so what does that measure right there, Chris? 80 degrees. We all agree that's an 80-degree angle right there, class? Anything hard about that? Okay, the next one we want to figure out is the measure of angle DFC. Sure, DFC. So Sam, we want to find this blue angle right here. Any idea how we would do that, Sam? This blue, you see the blue angle, Sam?
Yeah, I do. Not the green one, but the blue one.
Blue, Sam.
Alright, so thanks, Cody. I have no idea.
Okay, Sam. Okay. Do we know the measure of this angle right here?
Yeah.
Sure.
Why sure?
Because other people said yes.
Okay, someone tell Sam why we know the measure of that angle. Caitlin, why? It's vertical to the other 50, right? And the vertical angles by the vertical angles theorem are always equal, right, Sam? So Sam, if you know that this angle right here is 50, this yellow angle, right?
Yeah, you take 180, you subtract 50, and then you get CFT.
Right. And what is 180 minus 50?
130.
Okay, do we all agree that that's going to be 130 degrees, guys? Man, the color is very nice. Okay, very colorful. Any questions on how we did this? Give me a thumbs up if you feel fairly confident that you would be able to answer questions given a thing and knowing about vertical, linear pairs. What else do we have? Just all the good stuff. Right, guys? All right. Good stuff. Good stuff. All right. Now, the next thing we want to focus on is our good old-fashioned blah, blah, right? Okay. Our good old-fashioned blah, blah. Okay, this is where things start to get a little more serious. So, a couple things we want to talk about here. Let's kind of fill in the blah, blah here. So, first of all, what do we call a line that intersects two other lines, guys? Right. So, let's kind of diagram this out a little bit. So, we're going to call this T, line T, and that is equal to a transversal. Okay, a transversal, ladies and gentlemen, is a line that crosses two or more other lines. Now, these two lines over here, we'll just call them L. We use lowercase capital letters, lowercase cursive letters usually, and let's call this M, L and M. Okay. Now, so we have kind of a diagram here. Now, when a transversal intersects two lines, we don't know they're parallel yet, okay? Then we get 8 angles. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now let's go through and let's list out corresponding angles, alternate interior angles, and same side interior angles. Knowing that, we probably could list out the vertical angles also if we had to, correct? All right, so this is good review of corresponding, alternate interiors, and then also same side interior angles. Okay, so Austin, I need your help. Go and pull a stick, please.
Will.
All right, Mr. Will, give me some corresponding angles. Will, were you here for this?
I'm pretty sure I was.
Okay. All right. So Will, just guess.
3 and 2.
Okay, 3 and 2 are actually what we call same side interior angles. Here's a hint, Will. 1 and 3 are corresponding angles, Will. So I'm going to give you a pair, 1 and 3. Now the reason why 1 and 3 are corresponding angles is they're both in the top left of their group of angles. Okay? Does that help, Will?
Yeah.
Okay, so give me another pair.
5 and 7.
Okay, do we all agree that 5 and 7 are corresponding angles? I think he's yeah. You can do anything you want. Okay. These are your notes. So 5 and 7 are corresponding angles. Okay. All right, Will, nice job. Pull me another stick, Austin. All right, Rachel, give me another pair of corresponding angles. 2 and 4. Do we all agree with Rachel that 2 and 4 are corresponding angles? Bottom left and bottom left. I agree with that, Rachel. So now this is angle 2 and angle 4. Guys with me on that? Angle 2 and angle 4 are corresponding angles. I think the obvious, we'll stick with you, Rachel, on this next one. What would be the last two, Rachel? 6 and 8. Very good, Rachel. So now we're talking about 6 and 8. Those are corresponding angles, okay? Now we have a postulate here. But before we can do our postulate, ladies and gentlemen, we need to have a given. What is the given that we are required before we can start talking about corresponding angles? And it's postulate. George?
If the transversal intersects two parallel lines.
We need to know. So now I'm going to give you a huge given, ladies and gentlemen. Here's the given. Blah, blah. L parallels M. Now, things got a lot more. We can say a lot more things. So what can we now say, ladies and gentlemen, about those 4 pairs of corresponding angles? Since we just were told, Mr. Roden is just adding a nice little given there that L parallels M. What can we now say? They're congruent, right? And here's our little congruent symbols. Okay, so this is called the corresponding angles theorem. Corresponding angles theorem. I'm abbreviating here, guys. Okay, the corresponding angles theorem says if blah, blah. Does everyone understand what blah, blah means? 2 lines being intersected by a transversal and they're parallel lines. Okay, then if blah, blah, then corresponding angles are congruent, right? So the key is to know the blah, blah. The blah, blah is 2 parallel lines intersected by a transversal on a plane, on a flat surface. You guys with me on that? Okay. So, and by the way, this is not a theorem, Mr. Roden. It is a what class? It is a postulate. My bad. I apologize.
You're done.
Give me one more chance, Sam. One more chance.
You're done.
Okay.
The door.
All right.
The door.
Ladies and gentlemen, this is a postulate. It's an unprovable fact. It's just true because it's obviously true. All right. Now, alternate interior angles. So now we want to talk about our alternate interior angles. So let's talk about those really quick. Austin, can you pull me a stick on that? Let's just identify some alternate interior angles. All right, Mr. Tanner, give me some alternate interior angles. What is that, Tanner? Yeah, very good job, Tanner. Angle 2 and angle 7. Okay, Tanner, since we'll stick with what you got, give me another pair of alternate interior angles, Tanner. 3 and 6. So angle 3 and angle 6. Okay, you guys with me on that? Okay, so remember, it's kind of the Z deal. You guys remember the Z that we can make and the backward Z, right? Okay, so what do we know about the alternate interior angles theorem, Tanner? Very good. So this is the alternate interior angles theorem. Okay, so we have the alternate interior angles theorem. And then it's just if the blah, blah, right, guys? And we all know what the blah, blah is. Then Alternate interior angles are congruent. Again, the blah blah is a transversal intersecting two parallel lines on a plane, right? Okay. So the last thing we talked about here is same side interior angles. Okay, so Austin, pull me a stick. All right, Nicole. Give me, there's actually, in this case, there's two pairs of all same side interior angles. What are they, Nicole?
Angles 2 and angle 3.
Very good. Angle 2 and angle 3, right? And what else?
And then angle 6 and angle 7.
Angle 6 and angle 7. Okay, now, what do we know about the same side interior angles theorem, Nicole? Who can raise their hand and help her out? What's same side interior angles theorem? George, what do you got?
It's blah blah when the same side interior angles are supplementary.
Very good. If blah, blah, okay, they're not congruent in this case. And guys, you can clearly see that 2 and 3 are not congruent, right? Kind of see it, right? This one looks obtuse. This one looks slightly acute. They're not going to be always congruent. They're going to be supplementary. What? If blah, blah, do you guys want me to say the blah, blah, or you know the blah, blah? If blah, blah, then same side interiors are supplementary. Good job. Nicole, does that help? Okay. All right, guys. So what's next here? So let's just look here. I'm not going to assign this for homework because you already have homework. So tomorrow what we're going to do, bring this back, and you'll get a new one. We'll finish this one up tomorrow. Sorry, I spilled that. And then we'll do some examples on that third page right there. Sound good? And then we'll move on to some distance formula, midpoint formula, all that. How many found this refreshing your brain a little bit? You guys find it refreshing? Okay, all right. You guys like the study guides that I'm handing out? Does that work for you? All right. You'll get 3 of those.